Okay, we've had a look at the broader topic of ecologically sustainable development. We've highlighted the importance of the three elements of that, so economic sustainability, environmental sustainability, and social sustainability. I now wanted to drill down on the specifics of environmentally sustainable engineering and what we can and should do as associate engineers to ensure that we're considering the environment in all the decisions around our projects, in the implications that our project decisions can have on the environment itself. In terms of the three frameworks, I suppose, or perspectives I'd like us to have a look at just this week. The first one is to make sure that we take a global perspective. And really, I'm not necessarily talking about the global as the planet, but in some respects I am. But I'm asking you to step back from the project you're working on and look at it from a broader system standpoint before making decisions and understanding the environmental impacts beyond the immediate impacts on the piece of plant equipment, building, roadworks, and so forth that you may be involved with. We'll also have a look at different ways we might assess or measure environmental impacts, environmental impact assessments, environmental impact statements, environmental impact plans. For example, we'll just briefly touch on that. And we'll also have a look at the area of life cycle analysis as a means to assess the environmental impact of decisions that we take from an engineering standpoint. All right, now I asked you to take a global perspective, or at least the very least a step back from the particular projects that we're looking at. So we'll have a look at decisions we're taking within the overall system that we're actually working within. And the sorts of things that we need to consider are the natural resources that we're utilizing. Whether they constitute non-renewable resources, as you see on the left-hand side there, minerals, fossil fuels, and so forth, or some of the renewable resources that we can take advantage of, flow resources, as suggests there, trees, groundwater, and the likes, as well as continuous resources, solar energy, and so forth. Not exhaustive, but just to give you an understanding of the different levels of resources that are available to us as engineers. And what can we do to move from a reliance on non-renewable resources, finite resources, things that with the passage of time we're likely to run out of, and perhaps make some decisions around renewable resources. We talked about some of the ecological sustainable development movement from the 70s, 80s, and so forth. I touched on the need for us to look to lessen the amount of energy per unit of production, or per unit of what we produce, the reduction in the waste of that energy. Similarly, lessening the material usage per unit of production of the particular plant equipment and so forth that we're actually producing, and similarly the wastage thereof. So all of those will have implications for the designs that we undertake, and we need to make decisions around those with an understanding of the resources and natural resources that we're taking advantage of and utilizing, and understanding that not everything that we use is renewable, and as a consequence we might look for better solutions that will stand us in better stead over the longer period. Okay, just following on from the request, or perhaps even insistence, that you consider engineering decisions from a global perspective. I also want you to have a look at, I guess, as it suggests there, some of the resources flows in the broader human economy. So looking at some of the non-renewable resources down the bottom and the impacts that those can have on emissions and so forth from the various ecosystems and agriculture that we undertake, as well as on the right-hand side, industrial production, the waste that generates, the emissions that it generates as they serve human society, as you see up the top there, and the emissions that we generate as well. So the things that I want you to look at there is the amount of material use we undertake, and material usage that we undertake, as well as wastage. Similarly for resources, energy resources, for example, how much of that do we need per unit of production, how much of that are we wasting as well. So again, I want you to step back from the particular piece of equipment that you may well be involved with, or the particular project itself, and think about how do we lessen the amount of material used or material wasted, and how do we reduce the amount of energy as well as the amount of energy wasted as well. And again, look at those within the context of this diagram, which is very stylized, as you'd imagine, as you can understand, looking at resources flows in the broader human economy. And think about those when you're undertaking your next engineering project, significant or otherwise. I think it's still equally relevant. We need to have some formal measures of the impact that we're having on the environment. If we take a particular course of action with a particular mine site or a particular piece of plant and equipment, or a particular piece of civil works, or indeed construction activity, commercial, residential, or otherwise, what is the environmental impact that particular project is likely to generate? So again, what I would suggest to you, have a look at the EPA, Environmental Protection Authority's website, and get an understanding of their role, as well as our obligations as engineers, as engineers specifically, as it relates to the various acts and regulations from an environmental protection standpoint. And you'll have a look at what they say about environmental impact assessments, environmental impact statements, environmental impact plans, and so forth. I'm sure at some point in your careers you'll have come across any one of those particularly, but I do encourage you to have a look at the EPA's website and to get an understanding of our obligations in that particular area from a very practical standpoint. And the other measure that we can potentially use for assessing environmental impact is that of our ecological footprint. And the graphic you see in the bottom right there looks at different countries with their ecological footprint per capita, per person. And you'll see, for example, Qatar, Kuwait, UAE, all heavily oil-rich nations, as you would understand, and their significant ecological footprint there, down to you can see in the top row, the right-hand side there, the Irish footprint. About half that of ecological footprint, that is half that of Qatar, and then another group below that, top 10 African countries. Again, each of those much smaller in comparison to any of the more developed countries at the top as well. So again, ecological footprint is another means to assess the impact that we have on our broader environment. I mentioned briefly the need to consider life cycle analysis. This graphic really describes the life cycle analysis of a very simplistic product, that of a bottle of water. You can see their extraction, processing, production, marketing, distribution, consumption, and then ultimately disposal. And then hopefully on disposal, there's an opportunity to recycle that as well. So that's just one life cycle for a bottle of water. If the material is recyclable, then hopefully the opportunity for that life cycle to continue exists. I've mentioned in the past the aluminium industry. Having spent 10 years of my career in it, we were often criticized by environmental groups for the amount of energy consumed in the production of primary aluminium. And it's no doubt, it's quite high. It's about 30% of the raw material costs of primary aluminium. So that's when we first take aluminium oxide and reduce it, the reduction process from aluminium oxide, alumina, which is a aluminium oxide with hydrated aluminium oxide, and we turn that into primary aluminium. A third of the raw material cost there is actually power. So it's no surprise that most aluminium smelters are located close to the source of power, and you'll see that not just in Australia as well as but across the globe. But again, if you consider the life cycle analysis for aluminium, because it is infinitely recyclable, and more importantly than being recyclable, is actually very heavily recycled in Australia as well as other countries. the impact of that initial 30% raw material costs. Each time we look to recycle, the power component is only 5% of the initial power component, as an example. Those numbers, please don't quote me exactly on those, but a lot less than it was for the production of primary aluminium. So each time we recycle it, the energy component becomes less and less and less and less. So from an overall total life cycle standpoint, we need to consider that as well. I refer back to the Olympic Stadium in Sydney, 2000. We were lucky enough to have won the contract to produce the structural, the roofing for that material through one of our distributors and fabricators is for my business at the time in the aluminium industry. And the Sydney Olympics was touted as the Green Games. So we did get a lot of attention from green groups around the things I've just talked about. So we went through the exercise of the life cycle analysis for aluminium, not just for the first time it's produced, but for the proportion of times it's likely to be recycled and so forth, to show that it truly is a more environmentally sustainable option than perhaps was initially imagined. So again, just an example of life cycle analysis, and we need to be aware of that for any of the things that we are designing, in terms of what's the probability that it can be recycled, are we using recyclable materials and so forth, and so that it has the project has a life beyond the functional life of the plant equipment and so forth itself, such that we aren't creating an impost or a significant imposition from an environmental standpoint. This really follows on from the life cycle analysis diagram that I talked about previously, and it's really how I'd like you to conceptualize any future engineering works that you're undertaking, right? So I want you to have a mental picture of what you're undertaking is utilizing resources from the environment, so energy, materials, and so forth. We're operating within an economic system, so we need to make sure that whatever we produce is functional from a cost-benefit perspective, actually ticks the boxes and is economically viable, generates functional outputs that meet the requirements of the client. So be that a third-party external client or an internal client, depending on the organization you work with, but also looks to reduce the amount of waste, be that energy waste or material waste. So again, any future engineering project, conceptualize that process, conceptualize the design of that and the operation of that particular project, shall we say more broadly, because I know you come from a broad group. So whether it's plant equipment, whether it's building construction, whether it's civil, otherwise, and so forth. Understand that we're utilizing scarce resources, be the energy or materials that we're drawing from the environment. Remembering that the matter can neither be created nor destroyed. Now, I don't want to hear your views on Einstein and so forth. I don't think the impact of that's going to change too much of the matter that we've got to draw upon. But matter can neither be created nor destroyed, and similarly, energy, it just changes form. So we need to make sure that we're using those precious resources wisely. Making sure that, and having done so, that we have an outcome that's economically viable for our own business as well as for our client business. So we have a functional output, so something that actually meets the specifications that we've agreed upon initially with our clients or our customers, and also reduces the amount of waste in the process itself. So I just think it's a really, and it's this global perspective that I was talking about earlier, stepping back from the specific project that we're working on, taking off the blinkers from an economic standpoint, but considering the broader ecological sustainability issues, and considering the energy and materials usage, certainly considering the economic implications, but also from a waste perspective going forward as well, so life cycle and so forth. So I really just want you to use this, and it's not a complicated model by any stretch, as you can see, but understand have to take a much broader perspective around the decisions we take. Is there a better way of doing this? Can we reduce the material usage? Can we reduce the material wastage? Can we reduce the energy usage? And similarly, the energy wastage as well, but still provide a functional output that meets the design brief agreed with the client, be they internal, external, and at the same time generates an economic benefit to ourselves as well as our particular client. So I would ask you to utilize this approach in future engineering. Okay, that's the topic of environmentally sustainable engineering. Coming up next, we'll have a look at the topic, as you suggest there, socially sustainable engineering. The graphic that you see in front of you is Maslow's hierarchy of needs, which we will talk to during the next subtopic, amongst others. But I just wanted to preempt that.